This is Advanced Math Unit 3, Lesson 3. Six trig functions. Okay. These are six trig functions that you have used before. The first three you learned back in Math 2. The second set, the last three, you learned last year in Advanced Math. All right, so we're drawing our right triangle. If I put theta in this corner, now theta could have been in the top corner or the bottom corner. Theta's never in the right angle. Putting theta here, regardless of where I put theta, this would be my hypotenuse, correct? Regardless of where I put theta, that would be the hypotenuse. Putting theta here, this is the opposite side, and this is the adjacent side. Now, if I had put theta up at the top corner, this would be the opposite side, and then this would be the adjacent side. All right, you learned a little acronym, SOHCAHTOA. You learned that back in Math 2. Your Math 2 teachers taught you SOHCAHTOA. You may not remember, but they did. And it just helps you to remember what is sine, what is cosine, what is tangent. Sine theta, cosine theta, tangent of theta. All right. Sine of theta, according to this, how we memorized it. Now, some of you don't have to use that, and you already have memorized what is sine, what is cosine, what is tangent. But the OH stands for opposite over hypotenuse. Opposite over hypotenuse. So when I'm taking sine of an angle, it'll be the opposite length over the length of the hypotenuse. Cosine of theta, there's the C, is adjacent over hypotenuse. So if I'm finding cosine of theta, theta being in this corner, it's going to be the length of my adjacent side over the length of the hypotenuse. And tangent, opposite over adjacent. Opposite over adjacent. So again, if I'm sitting in this corner for theta and I'm taking tangent of this angle, it's going to be the length of the opposite side over the length of the adjacent side. Okay, so these first three are the original ones you learned back in Math 2. And then last year you learned the reciprocal functions. Reciprocal of sine is cosecant of theta. Cosine is secant of theta. And the reciprocal of tangent is cotangent of theta. All right. Reciprocal of sine is cosecant, reciprocal of cosine is secant, reciprocal of tangent is cotangent. If you don't have these already remembered, tangent and cotangent is pretty easy because cotangent has the word tangent in there. I just remember these, that S goes with C and C goes with S. So you never match the S with the S and never match the C's with the C's. So sine, cosecant, cosine, secant. And as I stated earlier, they are reciprocal functions, and reciprocal function means you flip your fraction. So instead of opposite over hypotenuse, you do hypotenuse over opposite. Adjacent over hypotenuse becomes hypotenuse over adjacent, and adjacent or opposite over adjacent becomes adjacent over opposite. All right. That was just a quick review from what you've learned in the past. Definite, all semester long, we will be using that. Number 1, find the 6 trig functions of theta. All right, there's the right triangle. I'm putting theta in the bottom left corner. I'm going to label this leg 18, this leg 12, and that's all the information I'm going to give you. If I'm asking you to find all 6 trig functions, you need to know the opposite side, adjacent side, and the hypotenuse. This is theta, so that's going to be the opposite. Opposite is 12. Adjacent is 18, but we do not know the hypotenuse. So what do you use to find the hypotenuse? Correct, Pythagorean's theorem. A squared plus b squared equals c squared. C being the hypotenuse, which is what we're looking for. So we're going to have 12 squared plus 14 squared equals c squared. You can go ahead and hit pause if you like, work it out on your own, and then hit play and see if you get the same answer. And that should be an 18. Sorry. All right, so 144 plus 324 equals c squared, and that should have been an 18. I was going too fast. 144 plus 324 is 468, so c squared equals 468. Square root both sides. Once you do all your breaking down and finding the prime factors, c ends up being, what is it, 6 root 13. And again, that's after you do all your prime factors. So 9 and 52, that's 3 and 3, that's 4 and 13, and you keep going and keep going. You end up with 6 root 13. All right, so 6 root 13, and we are going to find sine of theta, cosine of theta, tan of theta, and then we're going to take the reciprocals of each. Reciprocal of sine is cosecant, reciprocal of cosine is secant, and reciprocal of tangent is cotangent. So go ahead and hit pause, find each one, and then hit play and see if you have the same set of answers. All right, sine. Sine is opposite over hypotenuse, 12 over 6 root 13. I'll reduce in just a little bit. Cosine's adjacent over hypotenuse, adjacent over hypotenuse, so that's 18 over 6 root 13. I'll reduce in a little bit. And tangent's opposite over adjacent, 12 over 18. All right, when you reduce, 6 goes into 12 2 times, 2 over root 13. 6 goes into 18 3 times, 3 over root 13. And looks like 6 goes into both of those, so that is 2 over 3. Now, I've said to you in class before that we do not rationalize in advanced math. We've tested you on it these last few years since, I don't know when, middle school. No, math 2 maybe. We've tested you on rationalizing. We no longer test you on it, so it is okay to leave your answers in this form. If it bothers you and you want to rationalize, you would multiply top and bottom by root 13. And you'd end up with 2 root 13 over 13. 3 root 13 over 13. I'm not going to do it in class. I'm not going to do it in notes. It's up to you. All right, reciprocal of that is root 13 over 2. Reciprocal of that is root 13 over 3. I'd rather use the reduced forms because I don't have to reduce again. Reciprocal of 2/3 is 3/2. And that there is your answer. All right, number 2. Given cosecant of theta equals 10 over 6, find the 6 trig functions. All right. Now, when they give you something like this, you're going to pretty much change this to look like number one. Number one gave you a picture with two sides and you had to find the third. They're pretty much doing that here. They're giving you two sides and you have to find the third. So taking a look, they gave us cosecant. The cosecant is a hypotenuse over opposite. So you can make a little note. That is the hypotenuse, and that is the opposite. I would suggest you just quickly draw a right triangle. Some of you can do without, but I'm going to draw. I'm very visual. It doesn't matter where you put theta. If you put theta at the top, it would work out the same. Your picture would look different from mine, but it'd still work out the same. Okay, hypotenuse is 10, and opposite of theta, because my theta is here, is 6. So 6 goes over across the other side. And I'm looking for this leg here. And so I'm going to do Pythagorean's theorem. A squared plus b squared equals c squared. I'm going to call this A. I know that it's not C for sure because C is the hypotenuse. If I called this B, I could. It doesn't matter. I'm just going to call it A. A squared plus 6 squared equals 10 squared. A squared equals 100 minus 36. A squared equals 64. Square root and square root. We end up with a whole number, no radicals this time. A equals 8. So I'm going to erase this A, and in its spot I'm going to put the 8. All right, now this should be pretty easy for you to do sine, cosine, and tangent, as well as cosecant, secant, and cotangent of that triangle. So go ahead and hit pause, find them on your own. Don't forget to reduce, hit play, and check your answers. All right, sine of theta. Sine is opposite over hypotenuse, 6/10. I'll reduce later. Cosine's adjacent over hypotenuse, that's 8/10. And tangent's opposite over adjacent, that is 6/8. 2 goes into 6 and 10, it becomes 3/5. 2 goes into 8/10, that becomes 4/5. And 2 goes into 6 and 8, and that becomes 3/4. Flip them, 5/3, 5/4, and 4/3. Hopefully it's all review for you guys. All right, number 3. Determine the exact values of the 6 trig functions for theta. All right, I'm going to draw my picture. This picture will be given. -8, -15 is the ordered pair given for that point right there. All right, so this is the terminal side. So we've gone over this angle. It didn't give us the angle measurement, which is okay. They gave us the ordered pair, left 8, down 15, and asking us to find the 6 trig functions. When they're asking you to find the 6 trig functions and they don't give you a right triangle, like this one here, we drew our own. Same thing here, we're going to draw our own. And you learned last year, whenever you draw your right triangles, you always draw up to the x-axis. You never draw right or left to the y-axis. It's either up or down to the x-axis. So you're never going to draw your right triangle over this way. All right. To get to this point here, I went left 8 and down 15, and I know that because of the ordered pair. So I'm going to put that in. This is left 8, and this is down 15. So it looks like what I'm missing here is the hypotenuse. So go ahead and find that now. Hit pause if you'd like. This is the hypotenuse that I'm looking for. So negative 8 squared plus negative 15 squared equals c squared. 64 plus 225 equals c squared. Add them together, square root both sides. C equals 17. You guys can finish that off. All right, so if this is 17, we now have enough to find the 6 trig functions. Sine theta, cosine theta, and tan theta. All right, so sine, again, when you're doing these, if you remember from last year, theta, like where do I put the theta? Well, that's the right angle, so it's not there. Theta always goes in the corner closest to the origin. So not this corner, the corner closest to the, well, the corner that is touching the origin. All right, sine of theta. So this is theta. Opposite over hypotenuse is going to be negative 15 over 17. Cosine is adjacent over hypotenuse, negative 8 over 17. And tangent's opposite over adjacent, negative 15 over negative 8 becomes positive 15 over 8 because the two negatives will cancel each other out. All right, cosecant theta, secant theta, and cotangent theta. You're going to flip those fractions. I'm just going to leave the negative at the top, negative 17 over 15. If you put 17 over negative 15, it's the exact same thing. Negative 17 over 8 and positive 8 over positive 15. All right. Hopefully you guys are doing good so far. Number 4. Number 4 is a test question that kids have missed in the past. They've gotten better at it over these past few years, but still, I just still want to point it out. All right, the point is on the terminal side. I think what it is it happens so early they forget what terminal side is, and they just forget how to do these problems. The point is on the terminal side. Give me 1 second. Okay, so the point is on the terminal side of an angle in standard position. Find the 6 trig functions of the angle. Now you can see why people would miss it. It's so long and wordy. What the heck are they asking? The point is on the terminal side of an angle in standard position. Find the 6 trig functions of the angle, and here is the point. Negative 3, comma 4. When they give you a point like this, you're going to want to graph it. Just this one was graphed for you, number 3. When they don't graph it for you, that's what you're going to do. So let's plot the point, negative 3, 4, which quadrant would that end up in? Quadrant 2, you go left 3, and up 4. And that there is your point. Left 3, up 4. this point is on the terminal side. So if I connect to the origin, because that's always where I connect, this line here is your terminal side. And the point, can you see that the point is on the terminal side? In standard position. Okay, so this is what's going on. This is your angle here. Now remember, when you draw your right triangle, you always drop down to the x-axis, never the y-axis. You always drop down or go up like we did on number 3. Okay, so remember we talked about reference angles. We don't know this big angle out here. All we need to know is well, we don't need to know. We just need to know that the reference angle is in that corner. That's theta. All right, left 3 up 4 means I went left 3. That length here is -3, and the length here is +4, and that is enough for us to find our hypotenuse. So it's very similar to number 3, only the picture wasn't drawn. We had to draw it ourselves. Left 3 up 4, -3 squared plus 4 squared equals c squared. Go ahead and calculate that on your own. And you should end up with 5. Even with that being negative, that's going to become positive when you square it. 9 plus 16 is 25. All right, sine of theta equals, sine is opposite over hypotenuse, so it's going to be 4/5. Cosine theta is adjacent over hypotenuse, so -3/5. And tangent is opposite over adjacent, so negative. I like to put the negative at the top. I put -4/3. If you put 4 over -3 or the negative in the middle, that's perfectly fine. Cosecant, secant, and cotangent. All right, reciprocal would be 5/4, -5/3, and -3/4. All right, that's it for this lesson.